Hello everyone. Welcome to the series of these PYQ discussions of CSAT papers. So now we are still dealing with the 2024 paper. So after these questions, like we will go on to the 2023 paper. So let us look into the questions which we have left. We have solved the questions up to 60. After that, like 61 to 64 are our RC problems. So let us look into the 65th problem. The question is given in and followed by two statements. So it is as good as a statement question. Statement 1 alone, statement 2 alone, then both the statements, neither, all that thing we have to see. First question is, who received the least amount? This is the question. And for that, we have the data here. A certain amount was distributed among XYZ. We don't know the exact amount. They are asking who got the least. So let us look at statement 1. X received 4/5 of what Y and Z together received. 4 by 5 of what what 4/5 of what Y and Z received. This is what they are asking. So this is purely an equation in three variables. If at all you want to find out what exactly X has got, what exactly Y has got and Z, you have to have like two more equations. But they are asking least. So even comparative study if you do, then we can get the answer. But we have to see whether this will allow us to get the correct answer or not. In such case where like we are equating one variable to a fraction of sum of other two variables, and this fraction is less than 1. If this fraction was more than 1, then easily I would have said X is having more than Y and X is having more than Z. In that case, I would have told at least X is having the highest amount. But in this case, we cannot conclude anything about X, Y, and Z. So X is having like less than the sum of Y and Z. This is what is the interpretation. But if you look at the relation between Y and Z, you cannot ascertain. And relation between X and Y also you cannot ascertain. X and Z also you cannot ascertain. So here we cannot conclude anything with this particular thing. So here we can say that from statement 1 alone, we cannot conclude anything. Statement 1 alone, we cannot get the answer. Then Y received 2 by 7 of what X and Z got together. This is again same thing. 2 by 7 is less than 1 and the sum of X plus Z and its fraction is equal to Y. That means we cannot draw any relation between Y and X and Z and Y and Z. So that is not possible. So in this case, if this fraction was more than 1, then at least I would have said like Y is having more than X and Y is having more than Z, but that is not the case. Here also I cannot conclude. So statement 2 alone also I cannot conclude. Now I have to club both the statements. So first statement is saying X is equal to 4 by 5 of Y plus Z. Then second statement is saying Y is equal to 2 by 7 of X plus Z. Here see, we have two equations in three variables. In such case, we can compare X, Y, Z. Though we don't get the exact values of all the variables here, X, Y, Z, but at least we can compare like two variables. Let us try with that one. So here we want who is having the least amount. This is what we have to ascertain. In this case, you have to make at least one variable out. That means here X is there. So if you convert this particular expression in terms of X, then left hand side we can compare, and in two variables we can find the relation. So in this case, if I bring this 7 by 2 here, 7 by 2y is equal to x plus z. So z will go this side, x is equal to 7 by 2y minus z. So this is what we have. Here x is there, here x is there. Left hand sides are same, so right hand side you try to match. So in that case, 4 by 5 y plus 4 by 5 z is equal to 7 by 2y minus z. So if you bring y this side or y this side, let me bring this z this side. 4 by 5 plus 1 is 9 by 5z. So this calculations you have to be a bit quicker because this is basics. Then 7 by 2y minus 4 by 5y. 7 by 2y minus 4 by 5y. So in this case, what we can do is we can take the LCM as 10, then 2 5s are 10, 7 5s are 35, 35y, 5 2s are 10, so 4 2s are 8. So this is 9 by 5z. So 9 by 5z is equal to 35 minus 8 is 27 y by 10. 5 1s are 5 2s are 9 1s are 9 3s are. So what do we get here? Z is equal to, we get z is equal to 3 by 2y. Z is equal to 3 by 2y. In this case, z is more than y. That means y is less than z. So definitely z is not the contender. Z is not the contender. But we have to remember this one. We have to remember like between y and z. Y is lesser and z is more. Now z I am ruling out because I want the least. Now I want to compare this y with x. For that what I have to do? I have to take the equations with x and y. So let us remember this one. I am erasing right now because of the constraint of the space. So y is less than z. This is what we have to remember. Now again you consider those equations. X is equal to 4 by 5 of y plus z and y is equal to 2 by 7 of x plus z. Now I have got the result that y is less than z. Now I want to compare between x and y. For that you have to have z on one side and on other side x and y will be there. You can compare x and y then. So in this case 5 by 4 x, if I bring this side, and minus y is equal to z. In this case 7 by 2 y minus x is equal to z. Now z and z are equal. You can compare these two terms. So let me express these two. 5 by 4x minus y is equal to 7 by 2y minus x. I will bring x this side, 5 by 4 plus 1. So this will be 9 by 4x is equal to 7 by 2 minus y is equal to 5 by 2y. So here 2 1s are 2 2s are. If you keep x here and if you multiply 2 to 5, it is 10 and 9 will come here. So x is equal to 10 by 9y. 10 by 9 is more than 1. That means x is more than y. So y is less than z. X is more than y. That means y is less than x also. I don't have to compare z and x here. It is none of my business because I want the least. In the first case, I got y less than z. And between y and x, I got y is less than x. So in that case, who is having the least amount? Y. I can answer this question using both the statements. That is why in this particular case, we have to mark C because the question can be answered by using both the statements together but cannot be answered using either statement alone. So here we are getting the answer, but not by statement 1 alone, not by statement 2 alone. By combining both the statements 1 and 2, we are getting the answer. Let us go to the next question. So this is 65, I'm sorry, 64 we have left. Let us look at 64 also. Yeah, again same thing. We have to answer this question with the provided statements. What are the unique values of x and y where xy are distinct natural numbers? Distinct natural numbers start from 1 and it can go up to any number. Statement 1, x by y is odd. X by y is odd. They are asking what are the values of x and y. In this case, we get many options. For example, 9 by 3 is odd. Yeah, what are the values of x and y? 9 and 3 respectively. Let's say 6 by 2. It is also odd. So in that case, x by y, like 6 by 2, x is 6 and y is 2. We can have many values for x and y. So statement 1 alone cannot help us to get the answer. Next, statement 2 alone. X into y is equal to tau. X into y is equal to 12. So what all I can get? 1 into 12 is 12. 2 into 6 is 12. 3 into 4 is 12. And you can interchange these numbers also for x and y. So many values are there for x and y. So statement 2 alone will not help us to get the answer. So we have to combine both now. We have to combine both. So in that case, what we have to do? X by y is equal to odd. But x into y is equal to 12. In this case, what all are the values of x and y that are possible? X and y. What are the possible values? If x is 1, y is 12. If x is 2, y is 6. If x is 3, y is 4. If x is 12, y is 1. If x is 6, y is 2. If x is 4, y is 3. So these are the different combinations that we can get for x and y. But now they are asking x by y is odd. So when x by y is odd, we have to take x as a bigger number because we want to divide that bigger number by smaller number y. So we have to go for only those values. See here, 12 and 1, 6 and 2 and 4 and 3. See, if I take x as 12 and y as 1, it will not be odd, this will be even. I cannot take this one. But 6 by 2 is odd. 6 by 2 is odd. So I can take the values of x as 6 and y as 2. So this is possible. Next is 4 by 3. I'll not get a perfect natural number here. I mean, like we don't get an integer here. We'll get a fraction. So even we cannot consider these also. Anyways, these are bad because we want x bigger number. X bigger number in the sense we have to take these. So x by y should be odd. So x should be greater than y. So x value can be 12, y will be 1, x value is 6, y is 2, x value is 4, y is 3. These are the values that we have to consider. But 12 by 1 is even, 4 by 3 is a fraction, 6 by 2 is odd. So the values of x and y are respectively 6 and 2. So by using both the statements, we can answer. Again, in this case, the answer is C. Answer is C. By using both the statements, we can get to the answer. This is what we have to tick. Next question. 65 is also done. We'll go to 66. Yeah, same thing. They have asked the question. You have to tell whether statement 1 alone or statement 2 alone will help. Let us check. The question is followed by statements. Okay. If the average marks in a class are 60, average marks of a class is 60, then what is the number of students? See, whenever we get an average, how do we get it? Sum of the marks and divide it by the number of students. Now they have given average as 60, but we don't know sum and n. And they are asking us like how many students are there in the class. For that, I need sum of the marks. Okay. Now statement 1 is giving the highest marks in the class are 70 and the lowest is 50. Highest is 70 and lowest is 50. And they are telling the average of this is 60. They are asking us how many students are there. unless we get the sum, we cannot get the number of students, because we have the average marks here and we have the highest and lowest. Just by giving two values, highest and lowest, we don't know how many students are there between. To match this value of 60, I can match with any number. I can match with any number. I will just put everyone's marks as 60, 60, 60. Let there be 1000 students, let there be 10 students, let there be 5 students, let there be any number of students for that matter. So here I cannot conclude how many students are there in the class just by knowing the maxima and minima. I have to have the total of the marks or the sum of the marks. So statement 1 alone cannot help. Then statement 2, exclusion of highest and lowest marks from the class does not change the average. Exclusion of, so this is the reverse of this, what they are giving. So these are the number of students that we have, and highest marks and lowest marks I am trying to exclude. I am trying to exclude. That means the remaining students have the average as 60. Remaining students have the average as 60. But here there can be n number. Even by having one student, I can maintain this average. Even by having 100 students, I can maintain this average. Even by having 1000, we can maintain this average. In this case, like, we cannot conclude how many students are there. Even by clubbing both the statements, highest is 70 and lowest is 50, and throughout the average is 60. That's fine. But with n number of students, I can manage this. With one student also, with 1000, with n number of students, I can manage this data and get you the average 60. So here, unless we know the total marks of the students, we cannot get to the number of students. Even by using both the statements, we cannot answer this question. In this case, the answer is D. Answer is D. We'll go to the next question. Similar questions they have asked in 2024. This is the thing what we are getting since last 2-3 years. They are asking data insufficiency problem in our CSAT papers. Though the concepts are from the number system, mainly the concepts are from number system and the basics, but they are asking these type of statement based questions, like statement 1 alone can help to get us the answer, or statement 2 alone, or using both the statements, or even by using both the statements we are not getting to the answer. This is what we are trying to get. Here we have to have a lot of what you can say, a clear-cut idea. Sometimes we get influenced by statement 1 while we are reading statement 2. In that case, while you are reading statement 1 alone, you should not look at the statement 2 and decide. When you are looking at the statement 2, you have to forget what you have read in the statement 1 and you have to decide. When statement 1 alone and statement 2 alone cannot help you, then only you have to club both the statements and read and get to the answer. If that is also not possible, then you have to mark D. This is what you have to follow. Okay, 67 question. Again, kind of a data insufficiency. Okay, what is the question? What are three numbers? What are those three numbers? For that, there are three distinct prime numbers whose sum is a prime number. There are three distinct prime numbers whose sum is a prime number again. Whose sum is a prime number again. Okay. What are those three numbers? Their sum is less than 23. Their sum is less than 23. But it has to be a prime number. The sum of three distinct numbers should be a distinct prime number, should be a prime number. Then their sum is less than 23. This is what we have to check. First, let us look at the numbers which are prime. 2, 3, 5, 7, 11, 13, then 17, then 19, then 23. So let us stop here. Let us stop here because the sum itself has to be less than 23. Less than 23. Now, go with the smallest sum that is possible. 2 plus 3 plus 5 is 10. But we want a prime number. We want a prime number. So the sum cannot be an even number. And we want three numbers. We want three numbers. Among those three numbers, if one is even, other two are odd. So the sum will be even. So I cannot take 2 in these in this calculation. I cannot take 2. So we have to deal with only odd numbers because we are looking for 3 odd numbers, indirectly 3 prime numbers, but they have to be odd because we want the sum as a prime number. That has to be an odd number. Only even prime number is 2. I'm not using that one because I'll get the sum as even if I use 2. So other even prime number we don't have. That is why we have to look for only the odd prime numbers here. So now 3 plus 5 plus 7. 3 plus 5 plus 7 is 15. This is not a prime. This is not a prime. I'll go for next few numbers. 5, 7 and 11. 5, 7 and 11. 5 plus 7 is 12. 12 plus 11 is 23. But the number has to be less than 23. So if you go further, it will increase and it will be more than 23. So now among these numbers only try to get a hang. Try to get a hang. 3 plus 5 plus 7 is not possible. 3 plus 5 plus 11. Let us check. 3 plus 5 plus 11. 3 plus 5 is 8. 8 plus 11 is 19. This is a possibility. This is a possibility. Next. 3 plus 5 plus 13. 3 plus 5 is 8. 8 plus 13 is 21. 21 is not a prime number. Then 3 plus 5 plus 17. It will be 25. I am not looking for number more than or equal to 25. But here I am getting this one. That is 3 plus 5 plus 11. Now you look for other numbers like 3 plus 7 plus 11, 21. That is not a prime. That is not a prime. Then 3 plus 7 plus 13. That is 23. I don't want that. So in all these cases, if you do permutation and combination, we get 19 as a number. For 19, you have to have 3, 5 and 11. 3, 5 and 11. So these are the 3 distinct prime numbers that we have, which are giving us the sum less than 23. So we can tell statement 1 alone can help us to answer. Statement 1 alone can help us to answer. Now, statement 2, if you look at one of the number is 5. Now you forget whatever that you have done in this statement 1. Now you look only this. We want 3 prime numbers and there are 3 distinct prime numbers, and what we want, what are those numbers? One of them is 5. Okay, one of them is 5, let's say. Then what about other numbers? I can take any number, no? Because they are not giving any other condition. I want 3 prime numbers. One of them is 5. That's okay. That's okay. I can put 2 here. I can put 7 here. I can put 2 here. I can put 3 here. But I cannot get what are those numbers exactly. So statement 2 alone cannot answer this. But already since we have answered that this question can be answered using statement 1 alone, there ends the matter. There ends the matter. But you should not be blind. You should not be blind. You have to verify that again, whether your statement 1 alone is sufficient to answer this question. So here in this case, 19 is the sum, where 3, 5 and 11 are the prime numbers which are helping us to get the sum less than 23. That is what we have to focus. And here statement 1 alone can help us to get the answer. So answer is statement 1 alone. Next, what is the question? What is the question? Question is x plus y an integer? Is x plus y is an integer? This is what is the question. When all we can have x plus y as an integer. Okay. When x is a fraction and y is also a fraction. When x is a fraction, y is a fraction, there are possibility that it can be a fraction. When both of them are fractions, there can be a possibility that it can be an integer also. When both of them are integers, the answer will be integer. When one is integer, another one is fraction, the answer is fraction. When one is fraction, another one is integer, answer is fraction. I will not use this again because we can interchange x and y. But in this case, what we have to think is, if you want the answer as integer, both x and y should be integers, or both x and y should be fractions, but particular fractions. Any fraction, no, will not get the answer. If it is 1 by 3, it is 2 by 3, we'll get answer as 1. There is a possibility. There is a possibility. But if one is fraction, another one is integer, definitely we'll get the answer as fraction. So this is what we have to check here. Statement 1 is telling 2x plus y is an integer. 2x plus y is an integer. In this case, if both x and y are integers, then integer into 2 is integer, so we'll get integer. In this case, x and y can be integers, just can be integer. But if they are asking like, is x plus y an integer? Yes, is an integer in this case. But what if this 2x, if 2x is a fraction and y is also a fraction? If 2x is a fraction and y is also a fraction, I'll give simple example. If x is 1 by 3 and y is 4 by 3, 2x is 2 into 1 by 3 is 2 by 3 plus 4 by 3 is equal to what? Is equal to 6 by 3 is equal to 2. In this case also, both are fractions, we can get the answer as integer. So can I tell when 2x plus y is an integer, necessary x plus y will be an integer? Here x is 1 by 3 and y is 4 by 3. If I add them, do I get the integer all the times? No. Do I get the integer all the times? No. So here I cannot answer that whether it is an integer. Not all the time. Sometimes it can be integer, sometimes it cannot be. So in this case, I cannot answer this question by statement 1 alone. So similarly, x plus 2y, same thing. Just we are interchanging x and y here. So even by knowing this fact, we cannot answer whether x plus y is an integer or not. So it can be integer or it can be a fraction. So we cannot answer. But we have to club now. We have to club this these statements now. What they are telling, 2x plus y is an integer, then x plus 2y is an integer. This is what they have given. So now we have to club these things and we have to conclude. If I do plus 3x plus 3y is equal to an integer. 3x plus 3y is equal to integer. In this case, if I take x plus y and if I take 3 outside, this is integer minus divided by 3. In this case, x plus y is equal to integer divided by 3. So when I want the value of x plus y, it is integer by 3. It can be both fraction or integer. If this integer is multiple of 3, let's say it is 6, 3 ones are 3 twos are, then the answer will be integer. If it is 4 by 3 is not an integer. So even in this case, I cannot say that x plus y is an integer for sure. X plus y is an integer for sure. I cannot prove that. For example, if let's say in this case 2x plus y is an integer, x plus 2y is an integer. Let's say here 2 into let's say 4 by 3 and y is 1 by 3. So 8 by 3 plus 1 by 3. It is an integer. So similarly, if I apply like x is equal to 4 by 3 and 2 into y, so that is 2 by 3. So 4 by 3 plus 2 by 3 is 6 by 3. It is equal to 2. I am satisfying this condition. But when it comes to x plus y, x is 4 by 3 and y is 1 by 3. My answer will be 5 by 3, which is not an integer. So even in this case, I cannot conclude whether x and y are integers or not. So this is one of the toughest problem of this particular paper. People think that this is easy, but it is not that easy. Okay, when you have the clear-cut idea of what is an integer and what is a fraction, when we get an integer, when we get a fraction, then only we can conclude this one. So in this case, even by using both the statements, we cannot get to the answer. That means we cannot conclude that x plus y is an integer. Okay, quickly we'll look at other questions. Similar questions we have. Here, what is the question? What is the price of an article P? What is the price of article P? For that we have details here. 3 articles are bought for ₹50. So totally P plus Q plus R is giving us value 50, where the price of the article Q is 16. If Q is 16, then P plus R is equal to 34. If Q is 16, P plus R will be 50 minus 16, that is 34. So total value of P and R will be 34. Now look at the statement. Cost of P is not more than the cost of R. Cost of P is not more than R. In this case, P has to be less than or equal to R. So P should not be more than R means P should be lesser than or equal to R. P should be either equal to R or P should be less than R. So in this case, P plus R is equal to 34. If P is equal to R, if in this case P is equal to R, then P and R will be equal to 17 because sum of PR is 17. So P should be equal to 17, R should be equal to 17. But what is the statement here? The price of the article Q is 16, which is the least. Least article is at 16 rupees. Then P and R should be more than 16 for sure. So in this case, P and R are more than what? 16. P and R are more than 16. But if you try to prove that P is less than R, in this case, P has to be 16 and R has to be 18, or P has to be 15, R has to be 19. But they are telling 16 is the least. So P cannot be the other least. P cannot be other least. So in this case, only what we can draw is P is equal to R and R is equal to 17. So now, can you answer the question? What is the price of the article? P. It should be 17. Price of the article should be 17 because Q is the least. Even price of the R is what? 17. So P and R are 17, Q is 16. This is what is the conclusion. This is what is the conclusion for statement 1 alone. So if we have statement 1 alone, we can get the answer as 17. But let us look at the next statement also. Next statement. So here they are telling cost of R is not more than the cost of P. So in this case, R is lesser than or equal to P. Same thing. One thing is R can be equal to P. Another thing is R can be lesser than P. When R is equal to P, again, the value of R and P will be 17 because Q is the least. Q is the least. R value and P value cannot go below 17. Even they cannot be equal to 16 also because Q is the only least. So when you say least, only that particular number is least. You cannot have two least numbers. So among the given numbers, if one is the least, only one that alone number will be the least. So in this case, again, R is equal to P. If R is less than P, then it has to be 16, it has to be 18, or it has to be 15, it has to be 19, or it has to be 14 and 20. Where we cannot get this because Q has to be the least. Q has to be the least. So now R and P are equal to 17. Now, statement 1 or statement 2 are enough. Either statement 1 alone or statement 2 alone are enough to answer this question. That is why you have to be extra careful while reading these answers. Look at the answer 1. The question can be answered by using one of the statements alone. Yeah, it is either 1 or 2. But cannot be answered using the other statement alone. But here we are telling 1 or 2, not just 1. Here 1 alone can also get the answer, 2 alone also get the answer. The question can be answered by using either statement alone. Yes, either statement alone. Here this statement becomes wrong. The question can be answered by using both the statements together, but cannot be answered using the either statement alone. No, answer can be got by using one of the statements alone. Then the question cannot be answered using even by using both the statements together. No, this question doesn't arise, because when we are deciding the answer by the help of either of the statements alone, then we got the answer. We don't have to go for this option at all. Then answer is B. 70th question. P, Q, R and S appeared in a test. Okay, only data what we have is they appeared in a test. Has P scored more than Q? Question is P more than Q? Our answer should be yes or no. And all the times. Yes all the times or no all the times. Not sometimes yes and sometimes no. Is P greater than Q? Now look at the statement. The sum of the marks scored by P and Q is equal to the sum of the marks scored by R and S. So with this statement 1 alone, can we conclude P and Q together is equal to R and S. But how much P has scored and how much Q has scored, we don't know. It can be anything. P less Q more, Q less P more, or both of them are equal, we never know. So with the statement 1 alone, we cannot answer. Looking at the statement 2, sum of the marks scored by P and S is more than P and S is more than the marks scored by Q and R. Then can we conclude anything by this one? Don't think of this one now. Don't get influenced. Only think of this. Can you answer P is greater than Q? Though Q is at this side, it is the total of P plus S that we are giving as more than Q plus R. Again, whether P is more than Q or less than Q or equal to Q, we cannot tell. So, because we have the collective data here, P plus S, we don't know P more, S more, but P plus S definitely more than Q and R, but individually we cannot compare any variable here. None of the variables can be compared here because they have given the data of a group. So let us not conclude anything here. So to statement 2 alone. But using both the statements, can we see something here? Okay. So statement 1 is giving me P plus Q is equal to R plus S. And statement 2 is giving us P plus S is more than Q plus R. Yeah. In this case, we cannot conclude who is more powerful. P or Q or R or S. Anybody can the highest marks. Anybody can get the least of the marks. But here, P plus S together are powerful than Q and R. So now, if I compare this, I cannot compare who is more. Here, this group is more and this group is less. But again, can I compare the individual values of P and Q here? Can I compare the individual values of P and Q here? So when S is coming this side, when S is coming this side, Q and R are having less together. In this case, S is coming here and Q is coming here. I would say just by interchanging the place of S and Q, this group is becoming stronger and this group is becoming weaker. In that case, I can only tell that S is more than Q. Because just by bringing S here, the group value is getting better compared to the previous group. So S is greater than Q. This is what I can conclude, but nothing else. Between P and Q, no, we cannot compare. But between S and Q, yes, we can definitely compare that S is more than Q. But can we answer by clubbing both the statements? No. So in that case also, the answer is D. The question cannot be answered even by using both the statements together. Forget the statements alone. Now we'll go to the questions. Yeah, similar questions are there. Why I am solving these questions in length? Because this is the modern way of asking the questions by UPSC. So they are clubbing everything into the statement based. Statement 1 alone, statement 2 alone. Okay. Here, let us look into the question. 73rd question. Age of each P and Q is less than 100 years. Age of P, P is less than 100 and Q is also less than 100. But more than 10 years. That means P and Q's age will be between 10 to 100. P and 10 to 100 Q. So they are more than 10 years and less than 100 years. If you interchange the digits of age of P, the number represents the age of Q. So somewhere their age start from 11 and end at 99. But if you take one's age and reverse the digits, you will get the other's age. Now, what is the difference of their ages? They are asking what is the difference of their ages. For example, I'll take one's age is 45. If you reverse it, the other age will be 54. So difference is what? 9. Then, if one's age is 63, other's age is 36, then what is the difference? Difference is 27. If one's age is 58, other one is 85. So what is the difference? That is 27. So we cannot conclude like what is their difference of age just like that with only using this thing, but we'll go to the statement 1 alone. The age of P is greater than age of Q. Yeah, no problem. Age of P is greater than age of Q. For example, age of P is 54. The age of Q is 45, no problem. But what is the difference? 9. If age of this one, P is 62, age of Q will be 26. What is the difference? 36. So we cannot conclude anything just by reading the statement 1 alone. Okay, going to the statement 2. The sum of their ages is 11 by 6 times of their difference. So P plus Q is 11 by 6 of the difference between P and Q. So what we will get here? So 6 times P plus Q is equal to 11 times the difference between P and Q. So this is what is the same. But I have told you previously that whenever we take a 2-digit number and reverse it, their sum, that is sum of an original number and its reverse, will be 11 times of the sum of those 2 digits. This is the sum of the numbers is equal to 11 times the sum of the digits. And the difference between the numbers will be equal to 9 times the difference between those two digits. 9 times the difference between those two digits. So this is what we have to keep in mind. So when we say P plus Q will be definitely in terms of 11s. So 6 into 11s. So s is sum of the digits, and the other thing 11, the difference between P and Q, the difference between those numbers will be in terms of 9d. So in this case 11 get cancelled. So sum by difference is equal to 9 by 6. Sum by difference is equal to 9 by 6. That is equal to 3 by 2. That is equal to 3 by 2. So in this case, what we have to do is we have to find those numbers or those digits whose sum is equal to 3 and whose difference is equal to 2. Whose difference is equal to 2. So here we have to look for such numbers, or it can be in terms of 3. If the sum is 6, the difference has to be 4. If the sum is 9, difference has to be 6. Difference has to be 6. You have to look for those numbers. But no numbers exist like whose sum is equal to 3 and whose difference is equal to 2. For example, 2 plus 1 is 3, but 2 minus 1 is 1. So we cannot get this. So even here, the sum has to be odd number and the difference has to be even number. Even that cannot be the answer. But this we can. That is, sum can be 6 and the difference can be 4. Sum can be 6 and difference can be 4. What all are those numbers? 1 and 5. What all are those numbers? 1 and 5. So here, one's age is 15, other person's age is 51. One person's age is 15, other person's age is 51. We can go for 12 and 8 also. The sum has to be 12. And the difference has to be 8. So in that case, what we can do? We can get such numbers whose difference is 8, but the sum is 12. So you cannot get any such number whose sum is 12. You think of 2-digit numbers whose sum is 12 and difference is 8. We cannot get any such number. Maximum is 9 and 1. Difference is 8, but sum is 10. We cannot get that. So 15 and 51 are the answers that we get from statement 2. But who is who? Who is P and who is Q? P can be 15, Q can be 51. P can be 51 and Q can be 15. Even by statement 2 alone, we cannot decide. Though we are getting the answer 15 and 51, we cannot decide that one. But look at the statement 1. P is greater than Q. So P is equal to 51 and Q is equal to 15. This is one of the toughest problem. If you are not comfortable in the first round, you can take it in the second round or the third round. Don't waste your time initially. So this is a bit complicated. Only when you get this concept, then only you can solve this one. This is the concept of a number and interchanging the digits. So whenever you do the sum of a number and its reverse, that is 2-digit number, then the sum will be always 11 times the sum of those digits. When you take the difference of a number and its reverse, it will be 9 times the difference between the digits. This is what is the concept. On that we have built this one. This is not that easy for the first timers in the sense who doesn't know the concept at all. So for them it is difficult. So you have to take it in the second round. So using both the statements, I can answer this question. Yeah. Going to the next question. 74. Yes. We can read the question. Pradeep becomes either director or producer. Okay, main statement is what? Pradeep becomes either director or producer. Now, they are asking, statements where the first statement implies the second and the two statements are logically consistent with the main statement. Okay, let's read it properly. Statement labeled, a main statement is followed by four statements labeled P, Q, R, S. Choose the ordered pair of the statements where the first statement implies the second and the two statements are logically consistent with the main statement. So first implies the second, and those two, first and second, are logically consistent with the main statements also. So main statement is what? Pradeep becomes either director or producer. He has both the capabilities. He can become either director or a producer. So he becomes, not can become, becomes either a producer or a director. He has both the qualities or capabilities. Okay, this is what is the statement. Then coming to the statement 1, Pradeep is a director. Pradeep is a director. What does that mean? Pradeep cannot be a producer when Pradeep is a director. Then Pradeep is not a director. Yeah, that is also the negation of that. So Pradeep is not a producer. So P follows S. If or P implies S, not P follows S. P implies S. And other thing, Pradeep is a producer, Q. That means Pradeep is not a director, that is R. Q implies R. P implies S and Q implies R. And the two statements are logically consistent with the main statement. Yes, this is what is the conclusion. P implies S, Q implies R. Let us look at the answers now. Here, they are telling SP only. SP only. S is what? S is Pradeep is not a producer. If this is the statement, this is the first statement, then he is a director. When Pradeep is not a producer, he is a director. SP, yes. Then R. Pradeep is not a director. That means Pradeep is a producer. RQ. But SP only and RP only, RQ only, no. SP is also true and RQ is also true. Both SP and RQ, yes. Both SP and RQ will imply. That means S implies P, R implies Q. So both of them are correct and they are consistent with the given main statement. So this is statement conclusion problem. Such problems are increasing in these days. So please be careful. It doesn't have any maths, but it has a logic. So this case, yeah. If A plus B means A minus B, plus means minus, minus means multiplication, multiplication means division, division means plus. Then what is the value? This is BODMAS. 10 instead of plus, minus 30, instead of minus, multiplication 100, instead of multiplication, division, that is 50, instead of division, addition 20. Now, according to BODMAS, we have to do this. The value of this is 2. 30 into 2, this is multiplication, this is 60. So finally, this is 10 minus 60 plus 25. Then add the positive terms, addition, 10 plus 25 is 35 minus 60. 35 minus 60 is equal to minus 25. So this is a straight away. But while you are substituting the symbols, be careful. Yeah, this is related to equation problems. We have to be extra careful here, while we are dealing with the equations, because we might get more than two variables here. Okay. P means greater than symbol. Q means lesser than, R means not greater than, S means not lesser than, and T means equal. Okay. Then consider the following statements. Which of them are correct? 2xs, that means 2x is more than 3y. 3x is equal to 4z. 3x is equal to 4z. Then 9y is greater than. So if they are asking if this, then this. If this, then this. We have to prove that. 2x is greater than 3y and 3x is equal to 4z. See, here common things are x, but look at the coefficients. 2 and 3 are there. So what we have to do, multiply by 3 here, multiply by 2 to equate. So 2x into 3 is 6x is greater than 9y, and here 6x is equal to 8z. So what we can do, in place of 6x, I can put 8z. So this is what 8z is greater than 9y. But what we want to prove, 9y is greater than 8z. But here 8z is greater than 9y. So this is 1. This is exactly reverse of that one. If x is lesser than 2y and y is not greater than z. So here common thing is y. But let us look at the other way around here. When y is greater than or equal to z, then y is greater than, not greater than z. That means y is lesser than or equal to z. But here x is lesser than 2y. So to compare this one, what we have to do is, we have to make this as 2y. 2y is less than or equal to 2z. So what all I can do here? X, here x is less than 2y, but that 2y is less than or equal to 2z. In this case, what will happen? X is definitely less than 2y. 2y is equal to or less than 2z. So in this case, x is less than 2z for sure, because x is less than 2y. 2y can be equal, but x is lesser than this. So x will also be lesser than this. But they are telling x or z, that is x not greater than z. X not greater than z. But they are telling x can be lesser than or equal to z. This is what we have to prove. X is lesser than or equal to 2z. Yes, x is definitely less than 2z. X is definitely less than 2z. But is x less than z? We cannot tell. If x is less than z, we cannot tell. But they want us to tell x is less than or equal to z. Yes, x is less than equal to 2z. But whether x is less than z? No, we cannot tell that. X equal to z, x equal to z, x is less than 2z. So can x equal to z? Possibility is there, but we cannot tell perfectly. So statement 2 is wrong. But here what we have seen, even the statement 1 is wrong. We are not able to conclude perfectly in both the cases. In such case, neither of the statements are correct. Let us go to the next question. This is coding. This is related to coding. ABCD is written as 24. See, here 4 letters are there, but value they have given. So individual value, if we assign, it will not be 24. So something is happening with ABCD. But in the alphabetic order, A is 1, B is 2, C is 3, and D is 4. But do something with these numbers. Apply some logic. If I add them, this will be 10. If I multiply them, there will be 24. That means This is the product of their order. Product of their order. So EFGH also. Similarly, EFGH. If you look at E5, F6, G7 and H8. 5 into 6 into 7 into 8. I'll get 1680. That means the product of their order. Now IJ, K, L. IJ, K and L. I is 9, J is 10, K is 11, L is 12. So multiply them. 9 into 10 is 90, 90 into 11 is 990. Then into 12, the answer will be 11,880. This is a straight away problem. Yeah, other 3 questions in this paper. Again, these are very simple to solve. Pot is written as atop. So pot was there earlier. Reverse it, it becomes top and add A. This is what is the coding. Reverse it and add A in the starting. So similarly, trap can be written as part and add A. Apart. Then arena, reverse it. If I reverse it, it will be anera. Then add A. Add A. So this will be AANERA. AANERA. So simple thing. Next one, with respect to the missing numbers here, missing numbers. In this case, what we have to do? First, you try to find out the difference between the consecutive elements. 3 and 14, difference is 11. 14 and 35, difference is 25. 39 and 84, the difference is 45. Here I don't know. Here I don't know. But look at the difference of them. It will be 14. Here this will be 20. So look, it is in the increasing order. 14 and 20. Maybe you can add 26 just for a matter of chance. So 45 plus 26 is 71. 71. So 84 plus 71. 84 plus 71 is 155. 155. So next difference, 14, 20, 26. Next difference is 32. 71 plus 32 is 103. So 155 plus 103 is 258. This is what is the simplest problem that we have got, but let me explain it clearly. 3, 14, 39, 84, and we don't know this number, and we need 258. So first I would like you to take the difference. Here 11, here 25, and here 45. And this I don't know, this I don't know. So what is the pattern here? 11 and 25, what is the difference? 14. 25 and 45, what is the difference? 20. Now 14, 20, 6 more. So here 6 more. 26 plus 45 will be 71. You have to add to this. 84 plus 71 is 155. Now here 14, 20, 26, next is 32. But 71 plus 32 is 103. 105 plus 103 is 258. That means we are right. This is 155. So in such questions, if you go for number of iterations, what is that? You have to take the difference between two consecutive elements. In 2 or 3 iterations, you have to get the answer. Otherwise, you have to think of multiplying something, or you have to think of other logic in such cases. PQRST represent numbers 4, 5, 10, 12, 15, but not in the same order. It is not known which letter represents which number, not in order. But what we have is Q minus S is equal to 2S. What does that mean? Q is equal to 3S. That means one number is 3 times the other number. So what all are the possibilities? One number is 3 times the other number. See, 4 3s are 12 is there, 5 3s are 15 is there. So if if S is 4, Q will be 12. If S is 5, Q will be 15. So these are the 2 values that are possible for Q and S. Let us hold this thing here only. Then T is equal to R plus S plus 3. T is equal to R plus S plus 3. Then they are asking what is the value of this one. So here S value can be 4 or 5. If S is equal to 4 here, if S is equal to 4, then T minus R should be equal to 7 when S is equal to 4. If S is equal to 5, then T minus R is equal to 8. If S is 4, T minus R will be 7. If S is 5, T minus R will be equal to 8. So we have to look for T and R whose difference is 7 or whose difference is 8. So where all that 7 difference will come? So among the given numbers, 5 and 12 give us 7 and 4 and 12 give us 8. So in that case, T has to be 12 and R has to be 5. Yeah. When T is equal to 12, R can be 4. But what happens here? When T minus R is equal to 7, T is equal to 12, R is equal to 5, but S is equal to 4. In this case, if S is equal to 5, this is the thing. If T is 12, R is 5 and S is 4. If T is 12, R is 4 and S is 5. This is what the conclusion that we have around. That is the conclusion that we have around. So now R, S, T value we have. But they are asking P plus R minus T. When S is equal to 4, what is the value of Q? When S is equal to 4, value of Q is 12. When S is equal to 5, value of Q is 15. But look here, Q is 12 and T is 12. So this cannot be our answer. So Q is 15, T is 12, R is 4 and S is 5. S is 5. So only one remaining value, that is P, is equal to 10. So here P is equal to 10, R is equal to 4 and T is equal to 12. 10 plus 4 minus 12 is equal to 2. So the answer is 2. Yes, this is one of the difficult problem because here we get two values for Q and S. That is where the whole game begins. So with this, we have finished 2024's CSAT paper completely and comprehensively. All the questions, more than 50 questions we have solved in detail. So this is how we are going to deal with the 2023 paper also. So kindly hang with us for better clarity and concept. Thank you so much.